Tēnā koutou katoa, nau mai haere mai. It is my pleasure to warmly welcome you all to our information session for councils on the drinking water infrastructure study. Thank you for your interest and for joining us today. My name is Lucia Schweitzer. I'm the Research Engagement Manager for Te Niwha, New Zealand's infectious diseases research platform. The drinking water infrastructure study is part of a project funded by Te Niwha and is led by Associate Professor Tim Chambers from the University of Canterbury. Before we now hear from Tim and his team, I will hand over to the Director of Te Niwha, Tipora Thompson.
Tēnā koutou katoa. Ngā mihi nunu kia koe wene me whakatūwhiri koe nei hui. Rotere kia koutou katoa, ka tā mai I tēnei ata I te whakarongo kōrerotia I tēnei kaupapa tino whakahirahira. Kia ora everybody, my name is Lucy said, is Te Pora Thompson. I am the Director for Te Niwha, the Infectious Diseases Research Platform. Before we get underway, what I thought would be extremely helpful is to put into context where the project that Tim and the team will talk about where that sits in the greater scheme of Te Niwha, and therefore helpful to know who and what Te Niwha is and what it is that we do. So I'm going to do a very brief introduction and then I will hand over. I'm about to share my screen. And we will go slides. So as Lucy briefly mentioned, Te Niwha is the infectious diseases research platform that's funded out of the Ministry for Business, Innovation and Employment under the Strategic Science Investment Fund. We were established in 2022. Now, strategic investment funds, strategic science investment funds, which I'll just refer to as SIF, you get given a mission. I'm skipping ahead here. You get given a mission. Our mission for Te Niwha is to ensure that we have world-class research capability for future and emerging infectious disease threats and for our preparedness for pandemics. That said, it was important that we set the vision in place so that we're very clear where we were going to end up in the long term and something that we could all come together as a shared common purpose. And so that is to be strong, prepared, and a unified network. Strong that we have the research capability amongst us within this country, strong that we have the international linkages and the collaborations in place, prepared that we actually have the evidence and the research available to us given our time of need, and that more importantly, we are working together as a unified network. Now, that just doesn't mean the researchers that are involved in pandemic or infectious diseases research, but actually there's a wider network that we have in our vision of coming together. Just coming back to the name Te Niwha, we approached Rahui Papa very early on into our establishment of the research platform to come back with a name that would resonate and hold a line for us, all of us, bearing in mind our vision on what it is that we were striving for. And so he came back with this tongikura from King Etawhia. Kia ne te ngākau ki te whakau I ngā mahi a te whai mō te iwi. Be brave, be steadfast, and do what it is that you need to do for the best in the best interests of the people, what is best for and with the people, more importantly. We note this quite upfront and make a point of this part here to really make the point that all the things that we do, including what the team will talk to you about today, is holding the line, doing what is best for the people, keeping in mind again the vision that we have of a strong, prepared, unified network going forward, and being from the TLAs, I'm very sure that that resonates with you all. Te Niwha has a very its foundation document is what we have here, Te Kawenata o Te Niwha, the Te Niwha Charter. This is our, it's not the plan on the page, but it is the way in which we work, the way we do things, the values and the principles, all all on one shot there. You will see the vision and the mission at the top. You will note embedded in between our principles, values, vision, mission is Te Tiriti. What we have here is guidance across all of their articles and the way in which uh, Te Niwha, our researchers, our expectation on our researchers enact the mahi that they do. You'll come down to the principles here, and they're four principles, but very important principles, and it speaks to the quality of the research and the researchers and the institutions that we're involved with. So very briefly across this kawenata, and it's really important for context. Accountability is important. Research excellence, absolutely. Striving for the higher standards, absolutely. But that also comes into our implementation and the way in which we support research with the ethical standards, the regulatory requirements, but also their tikanga and their kawa practices determines the way in which we understand the roles and responsibilities, the relationships that we have, the partnerships that we form, and that those are healthy relationships, but committed partnerships, thinking back to our name, doing what is best for the people. And then it's incumbent upon all of us, you'll see right at the end there, and certainly not as a last means, rangatiratanga leadership, incumbent upon all of us, and a reminder for all of us to give and share and take on board the leadership. Now, the values that you see down on the left-hand side, they are one of a few, and I'm sure many of these will reflect your own council values, which briefly, integrity. All of our work is done with the absolute highest level of integrity, that we have respect and compassion for the mahi that we do. I think this webinar is a clear example of that respect for the work that others do and the way in which we can come together. But that's also about mahitahi collaboration, and then in kotahitanga, the sense of unity. This is the structure of Te Niwha, and look, I'm not going to labour here except to provide a demonstration that we are funded by MV. Uh, we are hosted by both ESR, which I'm sure many of you are familiar with, Institute of Environmental Sciences and research, but also by the University of Otago, who is actually supporting us as well this morning through the hosting of this webinar. At a given time, there's about 30 advisors that sit around myself and the team, all to support the research that we actually roll out. Down the bottom, what you'll see are the research priority areas that we do have. In a nutshell, this is and this is constantly updating. At the last count, we had about 102 projects within our research portfolio. Those projects are due to all deliver come December 10 with absolutely final reports, draft publications. But we are going through a process at the moment of ensuring that they have absolute success in what it is that they are gathering together in terms of the research. So this is a snapshot of the portfolio that walks through. You'll see on one hand, on the left-hand side, we have our strategic projects that we have commissioned, seeding grants, and the rapid research response that we have to emerging threats that we may face. You'll see on the right-hand side, there's about 51 direct investments that Te Niwha has in people and their projects, from some studentships all the way through to fellowships, masters, and PhD students in between. So you will see this that the portfolio is large. It's very considered. It is very target to uh, our mission and our vision of a strong, prepared, united network within Aotearoa. I will now hand over to Associate Professor Tim Chambers and his team to go on. But I did think that that context was very important. Now, I say that one as the director for this research platform. The other part being more recently, I sat on Hamilton City Council and for iwi and mana whenua as Māngai Māori, just before the Māori boards come in. So I can certainly um, resonate with some of the inquiries that are coming out of local government. With that said, Tim, I'm going to hand over to you and the team and stop sharing here. Ngā mihi.
Kia ora te Pora and Lucy for the introduction. And thank you everybody on the webinar for tuning in this morning to hear about our project, which is looking at drinking water infrastructure and enteric disease in New Zealand. So just before I dive in, three of the other co-investigators, Lucas, Matt and Mario, are also on the line, and they'll be doing the Q&A, trying to answer your questions as we go, but also they're online so we can have a chat about it at the end as well and answer any outstanding questions. But they're also on this webinar because they're the ones that are most involved in the work that we've been doing looking at the reticulation data, while the wider team has been looking to try and achieve the main aim of the project, which is trying to estimate the burden of disease from contaminated drinking water in New Zealand. And so really I want to focus on this assessment of drinking water reticulation in this particular webinar. I'll start by giving a bit of a background into why we're interested in the reticulation and what its relationship is with enteric disease. Then I'll provide you an overview of the methodology that we used in order to assess pipe condition. And then lastly, I'll go over some of the results. So as you're well aware, in order to provide safe drinking water, we need a multi-barrier approach. And that means protecting source waters, having effective treatment, and also having good reticulation. And so a couple of reviews have been done in the past to try and identify how much the reticulation contributes to drinking water related enteric disease. And one systematic review in the USA showed that between 1971 and 2006, that about 18% of those outbreaks were caused by contamination of the distribution system rather than contamination of source water or inefficient treatment. Likewise, in Canada, a recent estimate was that about 37% of all of the drinking water-related enteric disease was attributable to defects in the distribution system. And so one of the main mechanisms that's been proposed and what the strongest variable that's related to enteric disease are these breaches of physical pipe or hydraulic pipe integrity. So essentially, when we've got water outages. And so this is a meta-analysis of the studies that have looked at water outages and enteric disease. What you've got there is a forest plot. So anything that's to the right of the one is showing that there's a positive association between an outage and increased risk of getting sick. So all four of the studies are there. And then the red line there is the pooled estimate. So when you combine the studies together, what estimate do you get? And so what this meta-analysis is showing is that essentially you've got a threefold increased risk of getting sick when there's a water outage compared to a time when there's not a water outage. And so why am I talking about water outages when we've been talking about pipe condition? Well, pipes that are in poor, very poor condition are more likely to breach, or at least that's our hypothesis. And we, as part of this process, got some data from 11 of the councils about water outages. And we actually used our condition grading that we used in our methodology in the main paper to see how closely related our condition grading was to the chances or the likelihood of having outages in those pipes. And you can see here on the right, you've got the figure. And so this is a rate ratio. So how frequent are the outages in these other types of pipes compared to pipes that are in excellent condition. And you can see there's sort of a linear relationship there where you've got pipes that are in good condition compared to excellent conditions have a higher rate of outages, then even more for average, even more for poor, and even more for pipes that are graded very poor. So for us, this provides some mechanistic support for the assumptions about our pipe condition grading, which I'm going to go through in more detail later in this presentation. And so the aims for this particular part of the study were to collate and standardise a national database on the location and the condition of New Zealand's publicly owned drinking water reticulation. Then we wanted to investigate the differences in the drinking water reticulation quality and composition by council. And in order to do this, we had to generate a standardised method for assessing condition. And also look at the potential public health risks associated with pipe material and age. And the reason why we are focused on pipe material and age is because we had to use data that all councils had. So some councils had much more extensive data in their data set about the pipes in terms of like diameter or pressure. But in order to do a standardized method, we had to essentially use the lowest common denominator, and that was these two particular variables. And then sort of additionally with our problem statement is that the data that was available publicly or reported on was not of adequate condition for us to do our assessment. So what you've got here is in the latest Taumata Arawai report, 13% of councils reported pipes in poor or very poor condition. And that's the average value amongst the 67 councils, not the actual average of like the percentage of pipes. And so where this is problematic in particular is that we had about 25 councils that were reporting zero or near zero values for the percentage of their pipelines in poor or very poor condition. And for some of those councils that are reporting near zero, also councils that by our estimate have, between 30 and 40% of the pipes in poor or very poor condition based on age and material. So if you include 25 almost non-zero values into an average, then you're going to significantly drag down the average, the real average that there is nationally. So it's really hard to use this for any type of exposure assessment and therefore any type of burden of disease study. The other problem that we've got is that you've got, again, around 21 councils that are 0 or near 0% of their pipes that have actually received condition grading. And all of the councils take slightly different approach to condition grading, and we haven't been able to understand exactly how each council individually has done their condition grading. And so again, that makes it very hard for us to have confidence in these figures. And just to sort of reiterate the point, just to try and show my working here, what you've got here are the reported figures. And so you can see that this is the percentage of pipes that have received the condition grading, and you've got very wide values between councils, but very different values. You've got some people reporting 0% of their pipes are in poor condition, have received the condition grading. And then the variable over here, you've got the percentage of pipes that are in poor or very poor condition. So, reporting 0% of pipes that have got a condition grading, but 20% of them are in poor condition. And so it's just very hard for us to understand how these figures were generated and therefore have a national view of the current condition of the pipes. And then down the bottom there, you've just got the recreated averages that I've done there in Excel. So then what this figure here is showing you is there's a subsample of councils that had a condition variable in the pipe data set. And so the blue bars are essentially showing you what the raw data was reporting as the percentage of pipes that were in very poor condition. And then the blue dots are what were reported to Taumata Arawai. And you can see across the board there are quite wide discrepancies between some of those dots and the bars. And so, where the dots are contained within the bar, the reported figure that Taumata Arawai was lower than what was in the raw data. So the raw data suggesting that the condition grading was higher or more perhaps in poor or very poor condition. And then the inverse is true the other way there. So some councils reporting figure to TA that is actually higher than what was in their raw data. So for us, it's very difficult to see, there's not a systematic under or over reporting compared to the raw data. So you can't just apply some sort of multiplier to try and understand and address some systematic problem that's sort of random differences. And so the overall takeaways in terms of the problem statement for us, in terms of a data limitations viewpoint, was that there doesn't appear to be a standardized method for pipe condition or reporting on pipe condition across councils. And the data that was reported to Taumata Arawai is inadequate for us to produce nationally or regionally comparable figures, mainly because of these two main biases, the non-response bias in terms of people reporting zeros when it's not zero, and also the measurement biases where you've got different councils reporting condition in different ways. And so that took us to the starting point of this project was we needed to develop a method to try and come up with a standardized, nationally consistent measure of pipe condition with the data that we had available. And so the data that we had available came from these three different sources. So we got the reticulation information directly from the councils for 15 of those councils, and that was through email correspondence. An additional 15, we downloaded the publicly accessible reticulation files that are available online, which was very handy. And then about 37 of the councils, we got data from the Ministry of Education through a project that they did in 2022. And just in terms of the prior communication with councils, so we did contact 20 councils in March, April 2024, so last year. And this sort of gave an overview of the project, who was leading it, who was funded by, what we were trying to do in terms of establish a national burden of acute gastrointestinal disease. And then also specifically asking for information on condition grading of the pipes, if it was available, or confirming that there was no grading available, essentially, plus other types of information like the planned and unplanned outages. And just mention at this point, there were no concerns raised to us at the time about the project or what we were trying to do, and no one asked for additional meetings. So the data cleaning process of the starter was pretty extensive, and Mario is a hero. He did the lion's share of the data cleaning, but for some of these variables, there were sort of between like 600 or 700 values. So for pipe material, for example, there were 600 different pipe material values that were in there, and maybe just slightly different spellings of the same words, but still took a huge effort to try and compile all of the information from the different councils into a nationally consistent database. And so the only two variables that were consistently reported across the council were these pipe material and pipe age. And so therefore we use these two variables to try and generate our outcomes, which were life expectancy and pipes in poor or very poor condition. And the example here, you can just see some examples of the different pipe materials on the left for one supply, and then the age variable showing the installation, using the installation date to try and generate an age variable. And then the next question would be, how do you determine the life expectancy of a particular pipe? And it was, the answer is it's complicated, but in order to try and produce a standardized method, we had to try and sort of draw a line in the sand somewhere. And just to note that the WICS analysis, so the Water Industry Commission for Scotland, did note that there was a high degree of optimism bias for the maximum asset lives in New Zealand. And just to read the quote here, the reported asset lives are, however, much higher than observed by external benchmarks based on studies from Europe and Australia, despite ground conditions and seismic activity in New Zealand. And so we did actually ask councils at the time what they considered to be the useful remaining life or the life expectancy of these different pipe materials. But we got very different answers from different councils, and you can see, sometimes it's between sort of 30 and 40 years difference between the councils in terms of what they considered to be the life expectancy of that pipe. And while there are local factors that can impact the life expectancy of a pipe, age is by far the strongest variable that impacts the condition, and at least in the reports that we've read. So really we had to try and figure out what we should use as a life expectancy measure. And so what we did is we actually turned to the international literature, and we jotted down all of the most pessimistic and the most optimistic estimate for each pipe material. And so you can see that's the alley range, life expectancy range. And then for our analyses, we use the life expectancy midpoint. So we use the midpoint of that range to assign life expectancy. And then we also produced all of the results using the most pessimistic and the most optimistic values for life expectancy. And then to apply condition grading, we were really just looking at what percentage of the remaining useful life there was left of that pipe, using the pipe age and also against the benchmarked life expectancy. And so essentially anything that was graded as poor or very poor had 25% of its useful remaining life or less. And then our two main outcomes were past life expectancy. So you've got the same supply here, but you've got the pipes that are past life expectancy based on those benchmarks, and then the pipes that are in different condition categories on the right there. And so then the results overall was 57,000 kilometres of pipe, and the proportion of the pipes that are past the life expectancy were 18.5%. And then these values in the brackets are showing you if we took the most optimistic opinion of pipe life expectancy, then you get 8.7. If you took the most pessimistic view of life expectancy, then you get 28%. And then we did the same for the proportion of pipes in poor or very poor condition, and you got 30.7%. Here is the midpoint, 24.5% as the most optimistic, and then 42.5% is the most pessimistic estimate. And then what we did here is, this is sort of a repeat of the figure you saw before with the blue dots, ones reported to Taumata Arawai, and then the red dots now are the ones that we generated through our UC analysis. And so what I've just done here is I've just shown in the green boxes essentially where our estimate is coming very close to the estimate that was given to Taumata Arawai. In the red boxes, you've got ones where we've got quite a big difference between our estimate and what was reported. And, you know, that can be for a lot of different reasons. It's likely because councils have much better information about condition than we had available to us through the data sets that we had. But I think it also just shows that there's quite wide variability in how councils are determining pipe condition and also reporting on it through to Taumata Arawai. And so for us, the next steps is that this paper has already been peer reviewed at the Australian Journal of Water Resources. And we've already got the reviewer comments back, and there were no concerns raised about the methodology or the interpretation of the results. And so the revisions are due back to the journal by the 21st of February. So for us, that's the timeline that we're working towards. We've actually already addressed all of the reviewer comments, but we are holding off until we heard back and got feedback from the councils about this paper. And we had sort of a robust discussion about the paper and anything that we could change. But for us as the research team, unless there are like major fundamental flaws in the methodology that we've applied or misinterpretation of the data that was provided to us, the council data, I think we would be reluctant to make major revisions to the manuscript unless there were like fatal flaws of the paper. And that's all I've got now, and hopefully we've got a bit of time now for us to just walk through some Q&A, and if you've got more questions about specific parts of the methodology, we can do that. Unfortunately, we've got the team online as well, so we can do that. So thank you for your attention. Kia ora. I could get us started if that's useful. Yeah. I think Steve, you've got your hand up.
Thank you. Ash, I've got a question for you there, Tim. Thank you for the presentation, been really helpful actually.
Yeah, it was really good just to see the methodology. You can understand it. It's quite different numbers than what we had. And just Tim, just in terms of your comment that there was something like 600 variations in pipe materials, and you've narrowed that down to substantially less, I guess. My kind of potential concern or interest, I guess, is just understanding, how you did that. And considering some of the variances in pipe materials within the sort of finer classes for us, for example.
Yeah, it's a good question. I mean, when I said that there's 700 different values, a lot of those values, like a value is created as a new value if it just has like a capital in it, or has like an additional space something, but from like a data perspective, that's still quite a big issue because you've got to work out a way of making sure that you're not misinterpreting different values. But yeah, I mean, Mario was the one that was over more of the detail for that sort of aggregation. But essentially, he drew on the literature, and then we've had a data dictionary provided to us by another colleague here in the Department of Engineering that had sort of like a data dictionary about these things aggregate to this particular type of material, and they're pretty closely aligned. So we sort of we did our own approach using the literature, and then we sort of validated it against the data dictionary that was provided to us by a colleague in the Department of Engineering.
Yeah, would that be available to councils just out of word of interest in anything?
Yeah, I mean, it'd be great to get feedback on it. We were trying to do that initially to try and make sure that the assumptions that we made about the aggregation were appropriate, but it was difficult to get engagement. So yeah, I think we can probably do something with that, Mario.
One more question from me, and sorry, the Hastings District Council here. Just in terms of getting feedback to you, Tim, so there's feedback option is still available?
Yeah. We are working towards that 21st of February.
Right. And feedback goes to
me. You can just send it directly.
Yeah. 21st Feb. Because as Ashby mentioned here, like we do have condition assessments based on age, and it is quite a slightly, probably meaningfully different from how we've been categorised here through your methodology. And I'm just wondering, is it worthwhile submitting some commentary back to you on that difference in how we've done things? And I think your source of feedback for Hastings, we don't really have awareness around that, so we'd just like to do a couple of checks.
The source reference was the MOE 2022, because everyone here was sort of scratching their heads and thinking that we don't recall any engagement. But and I'm not even sure what that was, although I did note in the source file, other references were to open data, which we have ourselves as well. And you kind of explained it there in terms of the main data being material and installation date, and you're kind of aligned with how we do it in a way. The big variation is the age of the materials that you use. You're a lot more, a lot shorter lives than we have, which is sort of typical with what you explained. And I guess if everyone's on the same methodology, then that's fair enough. It's just making sure we're kind of just understanding, how we've got there. I guess in a real world context for us, a big, all of this is theoretical, obviously. In the real world context for us is sort of aligning that with actual failures. And until we sort of see a pincushion of breaks everywhere, different kind of story in Wellington maybe, but here it's not that, we're not seeing the geysers every day of the week kind of thing. So we don't feel like we're well out of step in terms of what our condition rates are telling us.
Okay. Yeah, I mean, I'd love to have the feedback, so if you just draw up, any feedback you've got, you can submit to us about, I think with the registration for the webinar, there were questions submitted, that would make it useful for us to understand like how to contextualize the results that we've got. And one of those questions is like, how do you do condition grading? And then, like you could add to that, what are the benchmarks for life expectancy that you're using for different pipe materials? And I imagine for a lot of councils in similar shoes as you, it's probably, that's the major difference, would be just like how restrictive we're being. That's why we use the range. But at some point you've got to report on something. So there's a range of values depending on how you feel about the life expectancy benchmarking,
No, sure. Look, thanks, Tim, and we'll submit a response to those questions. We've actually put those together. So, and
thank you.
Thanks again for this presentation.
Yeah.
I think you're on mute, Phil. Nixon.
Yeah, sorry, Tim. I think we crossed over each other. Unmuting. Yeah, Phil Nixon, South Taranaki District Council Mayor, and I have with me Herbert Denton, who is our GM of Infrastructure. Just listening to the team from Hastings, we very much agree with a lot of the comments that they were made, because we disagree with what you have said, or the result given in the report. I mean, our report to Te Niwha put us at about 23%, and you've got us over 50%. And on the assessment thing, we do a lot of different stuff with the assessment, like every time we have to cut into a pipe to put in a new feeder to whatever's cut out of that pipe is sent away for assessment. And so I think there's a lot more to it, to what you guys have done in far as the testing goes. And I think it's probably a bit much generalised to give us that, because when I first saw that come out, I was one of the ones that was strongly opposed to that being made public. I mean, if we've got pipes that aren't good, that's fair enough. And in our assessment, we're actually saying that pipes in very poor condition are 4.99. And so, yeah, we just were not happy with it. Have you got any comments there to add?
Yeah, I'm Herbert, as mentioned. Yeah, it's probably have a look at the different methodologies that people use. For us, for instance, yes, we use age, but that's largely theoretical. We do condition assessment. That's a major part of then establishing the actual condition of the pipe. But there's, have you guys actually looked at pressure management? Who actually does pressure management on those? Because if you manage the pressure well, the pipe will last longer. So I don't know if any of those were taken into account.
No, and that's like I said in the presentation, that's the limitation of trying to do a national assessment, is that essentially you have to base the methodology based on the lowest common denominator. Or you can do something where you're like, for those councils that have the full suite of information, this is the value that we get. But in this case, we were really just trying to figure out, well, if we had to do a national assessment where everybody was comparable using the same methodology, then you have to have the same variables available for each council. And in this case, the only variables that are available for every council were age and material, which can be good predictors of pipe condition. And then I think the thing that gave us additional confidence in the approach, at least at a broad level, was that our assessments of pipe condition, those pipes in poor or very poor condition, were correlated with pipe outages. So while, you know, for an individual pipe or for an individual council, that might be less true, at a national level, you know, that's what we'll base our exposure assessment on and do future epidemiological studies on, will be based on that. So, you know, I definitely take your point, and I think that's really probably important for us to draw out that, you know, these probably shouldn't be taken, you know, above and beyond what the councils are saying if they've got robust condition grading done. But for us, again, you know, like there are a number of councils that say that they have almost none of their pipes having condition grading. So I think if you've condition graded a good majority of your pipes, you have your own assessments and you've got operational information that you can draw on, I think it's totally reasonable to say that your estimate would be better than our one.
Yeah, so for us, it would be what is reported then, because if it's not true, based on the information that we have, yeah, you then can't actually go and report information that is not correct.
Yeah, your estimate is also an estimate, right? Everything is an estimate.
Well, actually,
It's a measured estimate.
Yeah, sorry, I don't totally agree, because some of those were condition assessed. It was sent to a lab. So, yeah, I think it's more accurate than the information that you have, to be quite honest.
Okay.
We are happy to actually forward you some input or information on the questions that you sent about methodology and so on. and we hope that those are actually taken into account.
Thank you.
Cool.
Grace.
Oh, wait, can you hear me? Oh, okay. Yeah, I'm Grace from Waitomo District Council. So, just first would just like to say thank you for the effort and then for gathering all those data from different councils and trying to get the common denominator. That's well appreciated. As for on my end though, unfortunately, on our council there has been very fast staff turnover. So in terms of the submitted information, unfortunately there have been some gaps in trying to find the working file on our end. And so as such, would we be able or would I be able to request for the raw data that you use for those ones and just try to bridge some gaps on where that source data is coming from? And then also, are we can I also request for that very source data or very raw data on how you came up with that estimate for by using just the material and the material age and life expectancy, because I believe there's differences in the life expectancy across all councils. If I understand it correctly, you use the life expectancy. You came up with a life expectancy, common life expectancy, and then applied it to all councils, right? So I just because the result based on the page is that Waitomo is showing 35%. Well, the submitted percentage is I think 20% poor condition, but with your methodology, it's just showing, it's showing 35%. So if the paper will go out, and which I'm sure you would thoroughly discuss the methodology, but for some people or for some audiences in our council, they will just look at the chart and they will just go back to the council and why this and that. So at least we are prepared, or at least we can give context to whoever will raise their eyebrows on those numbers.
Yep, sure. Yeah, we can provide you the raw data and give you a life expectancy estimate that we used in the paper for each material.
Hi, I was just wondering if I could jump in. I can't find where to put up your hand, so excuse me, I'm not used to using this particular thing. So apologies for this. Can I just, I'm James Ferry, I'm from Hamilton City Council. Hi Steve, nice to see you again. I used to work over in next door to Steve back in the Hawke's Bay, so small world, eh? Anyway, so can I just paraphrase what this thing is, the research is about? Basically, what you're saying is that you've got the general view is that the more burst pipes you have, the higher the risk of enteric diseases.
Yeah.
General thing, and that you're trying to get a national database to say what pipe condition is like. The information you've got out of councils, you're not too sure the quality of it because every council is doing something different. Essentially, what you've said is that you can basically work out what the condition of the pipe is, or the based on a relationship between age and material. You've gone and had a look at international stuff and actually seen what the age, the life expectancy is for a different material of pipe. You've got a whole bunch of pipes data from different councils. You've had a look at the ages of them. You've put that into a bit of a model. You've come up with a thing which says these ones of these age of this type is going to be high risk. And now you're going through a process of trying to calibrate that. In some cases you have calibrated. I realise that we've just been hit with another Lagoima asking us for a whole bunch of information about pipe bursts, reactive and unplanned maintenance, etc., where you're calibrating your model based on the idea of saying, how true is this data to say about what the life expectancy is based on the failure rate of pipes. Am I right in where you're at?
Yep.
And
Very good summary.
essentially, what a
James,
lot
do
of
you have a
councils.
question? Kia ora, James, is there a question in there? I think we've
Oh,
had the
there is a
recap
question.
three times through. If we
Yeah,
can
yeah,
come
yeah.
to the question, that would
Well,
be
that
good.
is the question. I just wanted to make sure that my understanding was correct on all of that, because obviously I'm, going to be taking that back to other people, and I just want to make sure that I hadn't missed anything. So essentially, what we're doing in this with this paper is that we have, regardless of what the councils have put together as their own methods of condition assessment, life expectancy, and what have you, you've tried to come up with a national standard for life expectancy, and at the moment it's based on age and material based on international studies, and you're trying to do that to understand what the failure rate of pipes is.
Yeah, perfect.
I think your question's a wee bit leading there, James. I'm going to ask you to put that into a statement of which we can share out with everyone else, just to be clear on the words that you are using in there. Thanks. Do we have any other questions, or anyone else seeking clarity on the...
Also unsure of how to put up my hand, so if it's all right, I'd like to throw in a comment about the contextual piece, and I've also chucked into the chat the New Zealand Gravity Pipe Inspection Manual, which has been recently released and hopes to bring some consistency to the way that we condition inspect our pressure water pipes, noting that it's very different from gravity pipes where it's a lot easier to do pipe inspections. So I guess just one comment in terms of contextualizing the information, and I wish, having reported on pipe condition myself at a national level for years, we'd done this better at Water New Zealand, but I think it's really important to note that it's not a failing to have not inspected all your pipes, that inspecting pressure pipes is a really expensive exercise, and actually our communities would balk if we spent a whole lot of money inspecting non-critical pipes. Our rates would be through the roof. So I think that's, in terms of context, what I wanted to say. And then I guess for everybody else on the call, as well as you, Tim, I mean, congratulations on bringing this database together, and I appreciate that there's concerns about the way the information's been presented and that there's discrepancies with the councils. But I guess I also just want to offer, having heard councils talk for years about the value that there would be in having a national pipe database, I guess I have a question about, for you and for others, if there's been thoughts on what the opportunities could be for this database going forward, because we have a lot of, I mean, for example, James mentioned he's getting hit with lots of leguimas. I think Grace mentioned there's a lot of problem. Well, it's been difficult to hold on to information with lots of staff turnover. And also as a sector, we've talked about the benefits that could come from being able to do national pipe database failure assessments and collectively have a bigger knowledge base to understand materials and how they fail over time. So I guess I have a question about what the future opportunities might be for this work, and how we could use the resource going forward.
Yeah, I mean, that's a great question. Thanks for that and for the background. I mean, the future for the database, it is tough because until there's a data standard being applied, it's the huge, I mean, it took us the best part of a year, to try and collect the information and standardize, and we only did it for 2 variables. So it's like, if you want to do it, there has to be some level of data standard across councils that everyone's feeding into similar. At least there's like 6 or 7 like key variables that must be done the same way, and then you can still maintain your database the same way that you otherwise would have, and so then that would make things a lot easier to integrate and to update. So like, again, like some of these data sets that we're using are probably not the most up-to-date data set for that council, but it's impossible to just add in the new information again because it would require another whole data cleansing exercise, which again would take another year. And then by the time we finish cleansing the data, it would be out of date. So yeah, that's why there is value in being able to pull it together, have a data standard, and have it continually updated. I mean, that that would help. And then if you were able to pull in the condition gradings, from the councils, and there was some data standard for that as well, then you wouldn't have researchers externally trying to come up with some sort of data standardization. So like, we acknowledge the limitations of what we're trying to do, but in order to, as a starting point for the discussion to move forward, like, this is what we need to, where we need to go. So I think, if anything, hopefully the research will highlight the benefits of having a data standard to avoid sort of, the assumptions that we've had to build into our estimate. Steve.
I think we're back in Hastings.
Yeah, hi, it's Ash. Hey, just pretty much following on from what you said, in terms of acknowledging the variation with the councils, would you be prepared to publish some sort of statement to that effect, that there's a varying degree of methodologies and some may be more accurate than others, in terms of the comment from a previous caller, South Taranaki, was it, in terms of they felt they had a stronger sort of value. And the other thing, it follows on from what Leslie said as well, I kind of forgot to say this, roughly 30% of our water network is AC, and we apply a pressure and class methodology, which we deem to be more accurate than an age, although we do use age for the remainder. Yeah, look, I will engage Tim, and we'll give you a bit more information about what we do. And similarly to what Leslie said, I think what you're doing is really good, and there is a lot of value in it. And I guess the question is, everyone just has to be comfortable understanding the methodology. This is super helpful, this workshop. Thank you for that. And I think there would be great value in standardising some of the inputs, and rather than make it a big exercise for yourselves, if we all know what that standard is, we can supply the data in that fashion, and it can be readily updated in terms of your condition score.
Yeah, I appreciate that. That'd be really great. But it's like, you guys are probably happy to do that. I just don't know if everybody's happy to do that, and then if just one council doesn't do it, then you don't have a national data set, So I really do appreciate that. I feel like there has to be like a collective buy-in that this is of value.
I think the tough thing at the moment is it's a very politicized environment, local government, in the water space. So everyone's very sensitive around all this information for what it might be used in a political sense.
Yeah.
And when we talk about condition, and you're right, everyone's got a different way of doing it. And I think as long as everyone's treated fairly, then those relativities are fine. But sometimes there might be a reading into that simplistic, poor, very poor, in terms of what that actually means.
Yeah.
You can easily imagine it becomes a headline. The words very poor, whatever percentage, and for what that means and what people might think that means.
Yeah, and the point about the limitations of the different condition grading methodologies, I'm pretty sure it's already in the paper that we say that, but it wasn't in the initial press release that everybody saw, right? And so it's about how to effectively communicate the results from the paper publicly. That's done some, and so maybe there's more engagement to be done around the media release than there is around the actual paper, because the paper addresses these things.
Yeah, well, that'd be good. And like you say, a lot of people are just going to be reading the media release, not necessarily the paper.
Yeah.
It's
always the problem. But
yeah. I'm talking about the journalists, etc.
Yeah.
Thank you.
Yeah, appreciate it.
I'd note that we have a couple of minutes left before 10 a.m. Perhaps one more question. I might ask you, Tim, just or the team to reiterate to the time that you will receive any feedback up to. So note that you have to turn around the review back by the 21st of February.
Yes. Yeah. So if there's comments from folk, you can just email me directly. We'll try our best to integrate them, but yeah, I think it will be tough for us to completely overhaul the methodology given the reviews that we've got from the journal and our own perspective about what it's trying to achieve as a first step. So yeah, I'm very happy to take the feedback, read through it and work, it's a work in progress. This is just the first step.
Kapai, I might wrap us up then, but I do want to touch on what was raised by Hastings, because you're absolutely right. We're in a very politicized environment. So it would be great actually to work together and get to a point together on the comms going out. I can see both sides of it. I think from my experience sitting in council, on one hand, I see an opportunity in being able to standardise and come together on that. That requires a lot of investment, however, and we're very well aware that we're trying to attract more investment rather than spend it. I think what I'm saying is I note the challenges that local government are facing. Water is a great big one in there, and being able to communicate back to your own constituents what is going on, where those rates are going to. So I actually really do feel for the life of the local government at this time. That said, all feedback can go back to Tim and the team. Te Niwha will, in partnership with University of Canterbury, Tim and the team again, work through some comms together. Saying that, I'm going to hand back to Lucy to close up our webinar. Ngā mihi nunu kia kata katoa. Thank you all for coming on board.
I would just like to reiterate Te words. Thank you all for coming online. Please have a look back at the initial email that has the Word document attached that Tim was referring to with some questions. If you want to engage further, please get them to Tim and the team as soon as you can so they can have a look. But also, if you have any questions, feel free to email Tim or Te Niwha and we will get in touch. We will also distribute the resource that Leslie had referred to. So you've got that at your hands. Thank you very much. I'll let you all head into your Mondays and then what I'm sure are busy weeks. And thank you again for Tim for your presentation and for everyone for attending this morning. Ngā mihi, ka kite.